So in this lesson, we are going to look at Surds. And this is a Form 3 topic. So by the end of this lesson, you should be able to do the following. You should be able to describe what is a Surd, or what are Surds. Then you should be able to differentiate between rational numbers and irrational numbers. Irrational numbers. You should be able to describe the order of Surds. Order of Surds. Then from there, we should be able to describe or to simplify Surds. Simplification of Surds. Then after that, we'll look at operations of Surds. So this involves addition, subtraction, multiplication, and division. And finally, we'll look at rationalizing the denominator. So that is what we are going to cover in this topic. So we can start by describing Surds. So Surds, we look at Surds and we say an expression. So Surds, we can say expressions that do not have exact square root. Exact square root, or cube root. Cube root are called Surds. Are called Surds. An example, we know we can get the square root of 2, but to get the square root of 2, you need to get or to use a calculator or a mathematical table. So you can use a table of square roots, or you can use a logarithm table. And when you get that the square root, for example, if I use my calculator, I get the square root of 2. It gives you a number that has so many decimals. So we have 1.414213562, and it on. That is how the number of the numbers that the calculator can display, the decimals. So this root 2 does not have an exact square root. So that's what we mean. So root 2 is a Surd. Root 5 is a Surd. We have the cube root of 36. The cube root of 36 that doesn't have the exact cube root. The cube root of 16. So 16, the root of 16 is 4. That has a square, that has an exact square root, but when you get the square root of, that is cube root of 16, it doesn't have exact cube root. So all these are referred to as Surds. These are Surds, and we have very many, as we are going to see in this topic. So let's look at the next thing. So here we look at rational and irrational numbers. So we start with rational numbers. Rational numbers are those numbers which you can write in the form of P over Q, where Q is not equals to 0, because when a number is equals to 0, we say that that fraction is undefined, or it is infinity. We don't divide a number by 0, and therefore we have numbers like, we can give examples of rational numbers. We can say 2 is a rational number. We can say 1 over 2 is a rational number. 3 over 4 is a rational number. So actually we can write, let's write here, rational numbers. Examples, that is rational numbers. So we have said we have 2, we can have 1 over 2, we can have 3 over 4 is a rational number, we can have 1 over 4, we can have the root of 4, we can have the cube root of 8, which is 2, that is 8. We can have the square root of 9, which is 3. We can have the square root of 25. We can have the cube root of 27, which is 3. On and on and on. We can go on, rational numbers. Then irrational numbers are those numbers which we cannot write in form of P over Q. And these numbers, that is irrational numbers, are like the square root of 2, we have the square root of 3, we have the square root of 5, we have the square root of 10, we have 3, the square root of 11, we have the cube root of 16, that is, we can say the cube root of 25. Such numbers we can go on. If you look at the irrational numbers, we can say they are surds. They are surds. These are the same numbers which we have called surds, which we cannot be able to get the root, the exact root, that is a square root or the cube root. So we can say surds are irrational numbers. Then from there we can say that we are going to look at mixed surds. What are mixed surds? So we have mixed surds. Now we know surds are those numbers which we cannot get the exact square root or cube root. So mixed surd are expressions that, these are expressions that is expressions that have, that is are a product of a whole number and a surd is called, or are called, mixed numbers, mixed surds rather. So we have a mixed surd. In simple words, mixed surds are those is a product of a number and a surd. For example, we can say 2 the root of 3. So you realize that 2 is a whole number and root 3 is a surd. So this is a mixed surd. So we can have another example. We can say 4 the root of 5. So 4 is a whole number. Root 5 is a surd. We can also say 4 the root of 5. The root of 5. So 4 is a whole number and 5 is root 5 is a surd. We can also talk of a half, the root of 7, the root of 7. So we can, this is a mixed surd. So that is how we describe surds. Then from there, we are going to look at order of surds. So let's look at that. So we say order of surds. So what is order? When we write a square root of a number, for example, the square root of 2, we don't put anything here. But ideally, it should be written like this, 2 to indicate the square root of 2. So we say that we can have, so if we write the square root of 2, okay, this is, let's write that properly. Square root of 2 should be written like that. But because it is the first one, we normally don't put that. So we say root 5. We can say the root of 10. We can say the root of 12. We call this surds, or we can say surds of order 2. So what we look for here is this number that we write before we write this, the root sign. So that is, these are surds of order 2. Then we can have the cube root of 2. We can have the cube root of 6. We write it like that. We can have the cube root of 10. We can have the cube root of 30. That is cube root. We say these are surds of order 3. Look at this number. That is what is determining the odd. So we can say the fourth root of 2. The fourth root means a number which, when you multiply it by 4, you get that number. For the example, the fourth root of 16 is equals to 2. This means that if you multiply 2 times 2 times 2 times 2, you get 16. So that is what fourth root means. And therefore, we can write the fourth root, can also write the fourth root of 100, the fourth root of 150, the fourth root of 180, and we can go on. These are surds of order 4. So we can continue. We have, we can say the fifth root of 2, the fifth root of 10, like that. These are surds of order 5. So this number is the one that determines the order. So we can say, in general, we can write here, in general, if we have an expression, that is, if we have an expression, we have a nth root is a surd, then we say the order of the surd is n. So we say the order, that is the order of the surd is n. So we can be able to, so and this is where this is the number that I'm talking about, n here. It is the order of that. So we can have a look at a few examples which we can be able to look at. So let's have a look at example. Write the order of. So write the order of. So we can say, for example, A, we have 7, 7th root of 30. We can also have B. Let's say we have 6th root of 30. We have C, we have 10th root of, this is 10th of 50. And we have, here we have 8th root of 80. So, which we can put that is D. So you can pause the video. So pause the video. That is and write the order of these Surds. So I'll be able to show you how to do that. So I hope you have done that, and we can be able to write I can give you what you should have written. So when you are given the 7th root of 30, order of this order, this is or we can write this is a Surd of order 7, because the value of the n here is 7. So that is A. For B, we are given the 6th root of 30. So this is a Surd of order 6. The other one, we are given the 10th root of, so this is 10th of 50. So this is a Surd of order 10. And finally, we have the 8th root 8th root of 80, and this is a Surd of order 8. So that is how you do you describe the order in this case, and I hope you have followed what we have done. So the next thing that we are going to look at is simplification of Surds. So simplification this is simplification of Surds. So we have said a Surd is a number that does not have exact square root, cube root, fourth root, and so on. But we can have a Surd that is a product or has factors or is a product of two numbers where one of the numbers is not a Surd or has a perfect square root or exact square root or cube root. And therefore, to simplify a Surd is to write a Surd in its simplest form. Write a Surd in its lowest, or we can say simplest form. And I'm going to show you example how we do that. So let's say we are given the first one, we are given the square root of 18. This is a Surd because 18 does not have exact square root, but we can write this. We know 18 can be written as 9 multiplied by 2. So we have not changed anything. In square root, when we are given in this format, we are allowed to separate the root. So we can write the root of 9 multiplied by the root of 2. So this you'll be able. So we already know 9 has an exact square root. So that means it is 3. You multiply by the root of 2. So this is how you simplify a Surd. So this is a Surd, and its lowest form is 3 the root of 2. So that is how we simplify a Surd. Another example, we can say the square root of 48. The square root of 48 can be written as the square root of 16 multiplied by 3. That will still give you 48. And this is equals to, we have said we can separate, so that is the root of 16 multiplied by the root of 3. We know the square root of 16 is 4. Root 3 is a surd, so we cannot simplify any further. So you multiply by root 3. That's how you write that. Again, we look at C and say the root of 72. This is equals to, we can write 72 as 36. That is 36 multiplied by 2. That will give you 72. And this is equals to, we know, okay, we can separate the root of 36 multiplied by the root of 2, and we know the root of 36 is 6, the root of 2. And we can also have D. We have the root of the cube root of 54. So we can get this is the cube root of 27 multiplied by 2, which you can write the cube root of 27. You multiply by the cube root of 2, and this will give you cube root of 27 is 3. You multiply by the cube root of 2, and that is its simplest form. So with that, I think now you can see how we simplify surds. So you can try this. We can say A, the square root of 200. We have B, the square root of 12. We have C, the square root of 125, and we have D. We have D, the square root of or the square root of 54. So you can try that and see whether you'll be able to do that. So pause the video and try to simplify this so that you check whether you have understood what we have covered in simplification of surds. And very important, this is very important simplification, as we are going to see in what we are going to do next. So the next thing we look at is operations of surds. Operations of surds. So surds operations, we have addition, subtraction, multiplication, and division. So just like any other numbers, surds can be added. So you can say surds can be added. Surds can be added, and that is let's correct that. Added, subtracted, multiplied, and divided. So we can be able to do these operations. So we are going to start with the addition. So let's have a look at addition and subtraction. Addition and subtraction of surds. So we can be able to add surds, and we do this. I'll show you by example. So we can have 1. Let's say we have root 3 plus root 3. We can say this is equals to be able to understand this, let's say let A is equals to root 3. So we can say what we have up there is A plus A, and that will give us 2A. And because when you add A plus A, and because we had assigned that our a is equals to root 3, so this is equals to 2 the root of 3. So that is the simplest form of this we have added. So that's an example of how we subtract. But before we do other examples, there are few things that two things we need to note, and these are for you to be able to add or subtract. So we say to add or subtract surds, we have to look at the following. Now, the order must be the same. So, one, the order must be the same. What does that mean? You can see here we have root 3 and root 2. So that the order, these are surds of order 2. So you cannot add two surds where, or you cannot add a surd that is of order 2 and a surd that is of order 3. You cannot do that. That is, you cannot add the root of 2 plus the cube root of 2. This you cannot be able to do that. That is wrong. The order must be the same. Then the other thing we consider is the number under the root sign should be equal. The number under the root sign must be equal. Let's correct that. Equal. That is, you cannot add root 3 plus root 2. They must be equal. What this means is that if we are given the root of the cube root of 2, that is a surd of order 3, you are told to add the square root of 2. You cannot combine this. You cannot add this. But if you are given the root of 2 plus the root of 2, this will give you 2 the root of 2. Why? Because one, the order is the same. These are surds of the same of order 2. And the number under the root sign is 2. So the two surds satisfies that condition. So with that, so you have to keep that in mind, these two conditions, so that you don't mess up in adding and subtraction of surds. So with that in mind, let's have a look at several examples before we move to something else. So we have examples. So we have 3 the root of 7 plus 5 the root of 7. What do we need to check here? This is a mixed surd. So we have a whole number and we have a surd. So for us to be able to add, one, the surds, that is root 7 and root 7, the order is the same. So this is of order 2 and this is order 2. So the first condition is satisfied. 2, the number under the root sign is the same. So we have 7 here and we have 7 here. So we can be able to add this. So you can, just to show you how we can, we have the way we have done the first one, we can say let a is equals to the root of 7. So we have 3, so this will be 3a plus 5a. And when you add 3a plus 5a, that will give you 8a. So this is equals to 8a. But we have said that our a is root 7. So this is equals to 8 the root of 7. So I hope you have understood. You have understood that. But when you get used, you don't need to write the let a is equals to that. That's not necessary. In fact, you can do it in another way and say 3 the root of 7 plus 5 the root of 7. You see here, root 7 is common. So you can factor it out outside the bracket and say this is root 7. It is common in both terms. So here, once you factor out root 7, you will be left with 3 plus here you will be left with 5. 3 plus 5, that will give you 8, and therefore we get it is 8 the root of 7, which is the same as what we have obtained there. So that is how you simplify. You add two surds. Another example we can say, this is another example, is what about when we say a the root of 3 minus 3 the root of 2. So this is equals to, we just like we have done here, we can factor out. So this one we cannot be able to solve because the number under this root are different. Therefore, we cannot be able to combine. But I want to correct it and write this is root 3. So we factor out root 3, and we have 4 here minus 3, what is left. And this will give us 4 minus 3 is 1. So this is the same as 1 root 3. But you know, when you multiply a number by 1, it remains the same. So we have this is equals to root 3. So you can see how we have subtracted here. Just like we work with the rational numbers, that's the way we subtract the surds. So before we do another example, let's have a look at this. From the examples that we have seen, we can say that so we can say in general, we have seen that A, if we start with A, if we are given an expression like A, the root of n, plus B, the root of n, we can see the number and the root under the root is the same, that is n. We can be able to write A plus B, this into bracket, the root of B. Again, if we look at B, we have A, the root of n, minus B, the root of n, is equals to, we say it is A minus B, that is the root of n. I think we need to correct here. This is the root of n. So that you should note that we have seen that. And maybe if we look at one more example here, we can say, let's say we have the root of that is another example which we can do here. Then we have let's say 6, that is 6 the root of 3 plus 4 the root of 3. We can directly say this is 6 plus 4 the root of 3. That's what we mean. So it will give you 10 the root of 3. So very simple to work out that. Again, if we are given the root of 6, that is not the root, but we can say 6 the root of 3 minus 4 the root of 3. We simply say it is 6 minus 4 to bracket the root of 3, which will give you, this is 6 minus 4 is 2 to the root of 3. So you can see that is what we apply, that we can apply that. So when you are working, you don't need to do this. This was just to show you how we are able to add and subtract the surds. From there, we look at multiplication and division of surds. So we have multiplication and division of surds. So like I mentioned when we were starting this, we started on operations of surds. I said you can add and divide, add and subtract surds, and as well as you can multiply and divide surds. So we'll do this by use of example. So we can say example. If we take the, let's start with the A. If we take the root of 2, you multiply by the root of 2. Now, just to demonstrate this, we can say let A is equals to let A be is equals to root 2. So we can say A multiplied by A is equals to A squared. And therefore, the root of 2 multiplied by the root of 2 is equals to the root of 2 into bracket square. When you square, when you square the root, then you get the number under the root, that is equals to 2. So this is how you multiply. We can also multiply other two roots. So we can say the root of 2 multiplied by the root of 3, which we can combine and say this is equals to, you can write it here. We say that we can combine the surds. So we say it is 2 multiplied by 3, which will give you 2 multiplied by 3. You get it is the same as the root 6, so which is surd, and you cannot simplify any further. Again, we look at C. We can multiply 2 the root of 6. You multiply by this is 6 the root of 10. So when you have that, you multiply the whole number. So 2 times 6 is 12. So that is 12. The root of 6 multiplied by 10, which will give you 12 the root of 60. So that will give you the root of 60. But we talked of simplification. So this you can write 12. 60 can be written as 4 multiplied by 15, which is equals to, now we can say it is 12 multiplied by root 4 multiplied by root 15. This will give you 12. The root of 4 is 2, so we have to multiply by root 15, which is equals to 24. 12 times 2 is 24, the root of 15. Okay, you don't need to write all these steps. Once you get used to, you can just be able to skip some of the steps. So that is multiplication. We look at D. What about division? So we can divide 10, divide by the root of 2. So these are two sides. We are allowed to write root of 10, you divide by the root of 2. So when you write like that, you are also allowed to combine this. So it is 10 divided by 2, which is equals to 10 divided by 2 is 5. So this is the same as the root of 5. Then we have, let's have one more example here. We have 2, the root of 15. You divide by the root of 5. You are allowed to write 2, the root of 15, divided by the root of 5, which you can combine and write this is 2 Okay, you can say to divide by 1, but that does not make the difference, any difference rather. That is, we can combine this root 15 divided by 5 under 1 root sign, which will give you 2. 15 divided by 5 is 3, so it is root 3. So you can say we can be able to multiply and divide surds. But one thing you note, unlike what we have said on addition and subtraction, when we are multiplying, the number or under the square root sign does not matter. So as you can see here, here we have the number was the same. The number was the same here. Here we have root 3, root 2. The numbers are different. Here we have root 6, root 10. So we can be able to multiply that. The surds which have numbers under the root sign being the same. Then what we cannot multiply is when the order of the surd is not the same. For example, it would not be possible for you to multiply, that is the square root of 2, and that is we don't put that, square root of 2, and you multiply by the root of 3. That is a cube root of 2. That is not possible. So because this is a square root and this is a cube root, the order is not the same. So that is, you cannot be able to combine unless you now get the square root of 2, the cube root of 2. You cannot write this in form of surd. And therefore, we can make a conclusion and say, when you are multiplying surds, let's say we have the root of A, you multiply by the root of B, you are allowed to write the root of A multiplied by B. That's one you are allowed, which you can write AB. So we can say the root of A multiplied by the root of B is equals to the root of A and B. AB, that is AB, that is allowed. So you can take note of that. Very important when you are multiplying surds. Another one that we need to note is that when you are dividing, that is the root of, let's use the same color, the root of A, you divide by the root of B is equals to, you can combine this, the root of A divide the root of B. Very important. You also note that. So these two are very important when you are multiplying this, the surds. And you also note that when you have the root of A plus or minus B is not equals to, you cannot say that is the root of A plus or minus the root of B. When we are adding, you cannot separate, and that is very, very important. Before we conclude as multiplication and division, we are going to take another example. So we have an example here. We can write example. So what about when we are told to expand these roots, expansion of roots? We have plus the root of 3 into bracket squared. So just like you learned in form 1 expansion, form 2 expansion of algebraic expression, we can be able to use the same method to expand this. So you can write this is the root of 2, put the bracket there, plus the root of 3, put the bracket, and you say this is the root of 2, and you add to the root of 3. So this is equals to, now just like we multiplied in our expansions, we multiply the root of 2 by the root of 2, and we multiply the root of 3 by the root of 2 by root of 3. After that, we now come to the other one. You multiply that root 3 times root 2, and you multiply root 3 times root 3. So that way you have a combined expression. So let's start by doing to do that. Root 2 multiplied by root 2. We said when you multiply two roots and under the number under the root is the same, then we get that is equals to 2. So root 2 times root 3, we can combine that and say that is the root of 6. Okay, so that you follow what we are doing. This is root 2 multiplied by root 3. But you know we can combine this. We have already covered that. So we have exhausted 2. We come to 3. Root 3 times root 2, we can say it is plus the root of 2, the root of 3. When you interchange the multiplication, it doesn't make it. That is to say 2 times 3 is the same as 3 times 2. So I'm writing so that we can have this is the same. And then we have root 3 times root 3. We will be able to get this is 3, a whole number. After that, then we can be able to combine. Now these are whole numbers, so 2 plus 3, that will give us 5. Then this we can say this is a plus. We can combine this, that is the root of 2 times 3, we get the root of 6 plus the root of 6 again, which we can combine and say this is 5 plus, when we are adding, we said you add this and you get to the root of 6. I hope you remember how we were able to add the surds. So that's how you work out that. Let's have another example. So we can take another example here. And this one, we say, what about when we are given 2 minus the root of 5 into bracket squared? So like we have done with the first one, the only difference here we have minus, and this one is a whole number. So we can just expand the same. So it is 2 minus the root of 5. This is 2 minus the root of 5. And this you'll be able to get 2 times 2 is 4. 2 times minus root 5. Here it is important to note that the minus sign. This minus sign in front of our root 5. So this will be 2 times minus root 5. So that will be minus 2, the root of 5. Again, we have minus root 5 multiplied by root 2. Very important here. If you mess up with the minus sign, then you are going to end up with the wrong answer. So we have 2, the root of 5. And finally, we have this is minus root 5 multiplied by minus root 5. When you multiply a minus times minus, you get positive. So that will give you a positive 5, because root 5 times root 5 will give you a whole number, which is 5. So we can combine here the whole number. So we have 4 plus 5, that will give you 9. Then we have this is 2 root 5 minus 2 root 5. It will be minus, you add 2 and 2, you get 4 the root of 5. So that's how you work out that. Then still we can be able to do another example. Let's say we have so it's another example. I think, let me use that. So we are given 2 minus the root of 3, and here we have 2 plus the root of 3. We can multiply that and say this is 2 times 2. That will give us 4. Then we have 2 multiplied by root 3. And note here it is positive, so it will be 2, the root of 3. Then we have minus root 3 multiplied by 2. That will give us minus 2, the root of 3, minus root 3 multiplied by positive root 3. Take note of this minus, very important. So that will give us minus. Minus and positive will give us, when you multiply, you get negative. So this means that this will be minus 3. So we can now say 4 a whole number minus 3, that will give you 1. Then you have that is, or we can say 4 minus 3 is equals, because when these two, 2 the root of 3 minus 2 the root of 3, that will give you 0, and therefore this will give you 1. So that is correct. That's the way you work out that. Another example we can look at is, let's say, example is when we have, so we have another example here, which we are going to look at, and that is, we can say this is 2 the root of 3 plus the root of 7, and then we have into bracket the root of 3, then we have plus 4 the root of 11. Can have a look at this. So with this example, you can see here we have a mixed number root. Here we have 7, here we have root 11. So we just expand the same, which we can say this is the same as root 2 root 3 multiplied by root 3. So you realize that this will be okay. Let me write it in its whole. So it is 2 the root of 3, and we multiply by the root of 3. We also take this and that, so this will be 4 times 2 times 4 is 8. So we say it is plus 8. Then you multiply root 3 times root 11, root 3 root 11. Then we are through with that. We come to root 7 multiplied by root 3. So we can say this is root 7 multiplied by root 3. And finally we have plus, this is root 7 times 4 root 11. So this is 4 the root of 7 the root of 11. So we can be able to combine this and say this is equals to, now you realize root 3 times root 3 will give us 3. 3 times 2, that will give us 6. So when you get 6 there, then you can say this is root 8, that is 8 root 11, root 3 times root 11. So that can give us 8. We combine root 3 and 11, and that will be, we multiply 3 times 11, and that will be root 33. Then we come to this one. This we combine. This is the root of plus. We combine the root of 21. Combine the root of 7 multiplied by the root of 3. Then we have plus. This is 4. 4, we combine the root of 7 and 11. That will give us the root of 77. So looking at this, we don't have any term. We don't have, let's start with the whole number. We don't have any other whole number. If you look at the surds that we have here, the numbers under the root sign are all different. Here we have 33, we have 21, we have 77. So we cannot combine this, and therefore that is the simplest. We can leave that surd because we cannot combine any of the term. So I hope you get that. So that brings us to the end of our lesson. So what remains is for you to practice on what we have covered. Let me take you through what we have covered, and then I'm going to give you some questions which you can attempt and see whether you have followed what we have done. So remember when we started, I said by the end of this lesson, you should be able to describe what's a surd, or what are surds, and I'm sure you now understand what are surds. These are numbers that doesn't have exact square root or cube root or fourth root and such. So we have covered that. We also have looked at rational numbers and irrational numbers, and we have said irrational numbers are the same as surds. We have also looked at the order of surds, that is of order 2 when we have the square root, order 3 when we have the cube root, order 4 when we have the fourth root, and so on. We have also simplified the surd. When we are given a surd and the number under the root sign can be simplified, then we can do that. Then we have looked at operations of surds, that is adding, subtraction, and multiplication. We have not covered rationalizing the denominator. That will be our lesson 2. So that's what we have covered in all this. So this is irrational numbers and rational numbers. We hope you have followed that. Then we have looked at mixed surds which have a whole number and the part of it is surd. And we have order of surds. We have covered that. Then we have that is order. We have looked at simplification, like these ones. And then we have looked at operations, subtraction, addition and subtraction. And we have also looked at multiplication. So let me give you some questions which you can be able to practice on what we have covered. So these are the questions as I would like you to go through. I'll call them exercise or assignment. The same. So if you are able to go through all these questions, then it shows that you have followed what we have done. So the first one, I want you to express each of the following. Each of the following surds in its simplest form. Surds in its simplest form. So we have A. The first one is root 8. We have B. We have root 32. We have C. We have root 52. And we have D, which is we have root 1000. That is, and we have E, where you get the root of 250. So we covered this in our simplification. You can express these numbers in the form where you can be able to get the exact root of one of the numbers, the product of these two numbers. Then you can simplify that. So number 2, you copy and complete. This. So I have a table here which I want to draw for you. You can complete it. So here we have that. We have another row here, another column. We have another one here, and we have another one here. So this then we are going to have that. That is the first row. Then we have another row here. We have another row here. We have another one here. Okay. We have another one. And we have another one. So we are going to write this. So this is we have 4, the root of 3. That is the root of 3. Then we have a square root sign here. We have 4 squared, and here we have into bracket the root of 3 into bracket squared. Then here we have a square root of 16 multiplied by 3, and here we have the square root of 48. So that's a complete row. So the others that are going to follow, there are some missing parts. So this is where we have 2 the root of 5. Then we have the root sign. We have 2 squared. and this is into bracket the root of 5 into bracket squared. We have here, we have the root of 4 multiplied by 5, and we have the root of 20. That's also complete. So you note here that if you square if you get the square root here, you square 4, it is the same because the square root of 4 is 4 squared is 4. Here we have squared cubed, that is 3 square root of 3, which when you get the square root under the whole this big square root sign, you end up with this. So here, what have we done? We have put the square root sign. 4 squared is 16, so we have put 16, and instead of now root 3, we have put it 3 under the whole square root sign, where we heard that we can combine. So here we can now put the combine. So if you are told to simplify 48, you end up with. So this is just a manipulation of that. Then let's have a look at the other rows that follow. So we have this, you have 6. Here we have 6, the root of 3. So you can fill this. So we have that missing, this is missing, and here we have the root of 108. Then we have that is missing. Here we have 7 squared, and you put this in the bracket, the root of 2, that is square, this is missing, and here we have the root of 98. Then we have 13. The root of 10, we have that is missing. Here we have the root of 169. You multiply by 10, that is missing. And finally, we have 13, the root of 10. The others are missing. So you can fill that table just like we have by studying the first and the second row, you'll be able to complete that. So let's go to another question. So we have, this is number 3. We have simplify. So we have, we take A, 2, the root of 3, plus 5, the root of 3. We have B, we have this is 2, the root of 7, plus a half, the root of 7. We can have our C here, 5, the root of 11, then plus the root of 11. Then we have our D, where we have 2, the root of 9x, or under this root sign, plus 5, the root of 3x. We have A, B, we have E, we have 4, the root of 18, plus 5, the root of 72, and finally we have, okay, we have, that is our E. I think here we have minus 108, that is there, that's the square root. That is A. Then we have our F. Our F, we have 3, the root of x squared, plus 7, the root of 4x squared, put the brackets there, minus 21, the root of 16x squared. So we have our G here, we have 3, the root of 19, minus 2, the root of 19. Then we have our H. Our H, we have 4 divided by 3, the root of 125, minus 3, the root of 5. And we have our G, which is 4 over 3, the root of 27, minus a half, the root of 3. So we have covered that. when we talked of addition and subtraction. So you should be able to manipulate this. So let's go to number 4. We are told to simplify. So we have a, this is the root of 5 multiplied by the root of 2. We have b, the root of that is 2 root 3 multiplied by 5 root 7. Then we have c, we have 3 the root of 13. You multiply by 5 the root of 2. We have d, we have 8 the root of x multiplied by 2 the root of y. Then we have e, we have 2 the root of 3 multiplied by 1 over 5 the root of 5 multiplied by 5 the root of 13. So this covers what we covered in multiplication. Let's have a look at number 5. So number 5, simplify. So we have our A. A is supposed to simplify 56 multiplied by 4. B, we have the root of 72. You multiply by a half. We have C, we are supposed to get the root of 400. We have, let's put our D here. We have 5, the root of 125 multiplied by 6. Then we have E, A, B, C, D, E. We have the root of 625 multiplied by 9. We have F, which is, F, this is the root of 81 minus 16. And we have G, which we have the root of 150 multiplied by 360. So that's number 5. We have dealt with the multiplication operations when it comes to multiplication. Then we have number 6, simplify. So we have our A, the root of 81 divided by 36. Then we have B, the root of 625 divided by 100. Then we have our C, this is 243 divided by 26. We have our D, that is 17, the root of 200. You divide by 6, the root of 400. So that is, we'll get to E. E, we have, let's write that properly. E, we have 49 divide by 12, and this is all this, that is divided by root 96 divided by 4, or under the same root sign. And finally we have F. We have 16x squared y to power 6. Then we have the root of 18 x to power 8 y to power 4 divided by 8x cubed y, that is y squared, the root of 6xy. So with that, let's go to number 7. Number 7, we have evaluate, leaving your answer in its simplest form. So we have A, we have 2 plus root 3 Then we have 2 plus root 3. We have b, we have root 5 minus root 3. And we have root 3 plus root, that is root 2. We have c, we have root 5 minus root 3 minus root 2, not 3, and then we have root 5 minus root 2, and d, we have 3 root 2 minus root 5, and we have root 10 plus root 2. So this is an exercise of what we have covered. You can do this question and submit your work to me through the email that I'm going to provide at the end of this lesson, or you can just take photographs and send them through my WhatsApp through the number I'm going to provide